Welcome to the Web Security Bootcamp channel. In this video, we'll walk through the PortSwigger Lab SQL injection attack, querying the database type and version on Oracle. This lab is part of our ongoing series on SQL injection fundamentals. In the previous video, you learned how to determine the database type and version in a non-Oracle environment. If you haven't watched it yet, you'll find a link in the description, along with a direct link to the lab itself. Before we begin, a quick reminder about ethical responsibility. This content is provided strictly for educational purposes and for use in authorized security testing environments only. Never attempt to apply these techniques to systems without explicit permission. This lab presents a classic SQL injection scenario where the vulnerability exists in a product category filter on a shopping site. Our goal is to exploit the vulnerability and retrieve the Oracle database version string using a union select injection. SQL injection happens when user input is embedded directly into a SQL query without proper sanitization or parameterized statements. This allows us to alter the structure of the original query. In this lab, we're specifically using a union-based technique. That means we're appending our own select statement to the application's original query. As you've already learned, two conditions must be met for this to work. The column count must match and the data types must be compatible. Once those requirements are satisfied, the database will merge the results, and the application may display our injected data. For a deeper explanation, check out my videos SQL Injection for Beginners and Union Attacks Explained with Examples. The links are in the description. Now we'll begin testing the application. First, we test the category parameter by injecting a single quote and commenting out the rest of the query using double dash. If this changes the application's response, it suggests the parameter is vulnerable to SQL injection. Before we implement a union select attack, we first need to determine how many columns are returned by the original query and which of those columns can display text in the response. In this video, I'll use the order by method to identify the number of columns. An alternative approach would be using incremental union select statements. I'll start with order by 1 -- and then increment the index 1 by 1. As long as the query executes successfully, the column number exists. Once the database returns an error, we know we've exceeded the actual number of columns. Now we can see that the original query returns 2 columns. Once we have determined the correct number of columns, we can move on to identifying which columns accept text data using a union select payload. In this lab, we already discovered that the original query returns 2 columns, so our injected select statement must also return exactly 2 columns. To test whether both columns can handle text data, we use the following payload. Single quote union select a BC, D, E, F from dual --. Here a BC and D, E, F are test string values. We monitor the HTTP response in Burp. If the server returns a normal 200 response without an error, it confirms that the union statement is valid and that the columns accept text data. You'll also notice the word dual. In Oracle, every select statement must include a from clause. Dual is a special built-in table that Oracle provides for situations like this. It doesn't contain real application data, we just use it so the query runs correctly. Now we're going back to the lab and applying the payload. I've replaced the previous payload with our test union select query, and now I'll send the request to the server to see how the application responds. Notice that we receive an HTTP 200 response. For beginners, this is important. A 200 status code means the request was processed successfully. In other words, the database did not generate a syntax error and the application did not reject our injected query. Since the server responds normally, this confirms that our union query is valid and that the columns are compatible with text. Now that we've this, we can move on to retrieving the database version. I'll open the SQL injection cheat sheet and scroll to the section for database version queries specific to Oracle. For Oracle, there are two common ways to retrieve the database version: querying $version or querying $instance. In this lab, we use select banner from $version because the banner column typically returns a clear, readable string such as Oracle Database Release. Now I'll replace our test values, a B, C, and D, E, F, with the actual version query. The payload becomes !union select banner, null from $version --. Here, banner retrieves the version string. Null is simply a placeholder for the second column, ensuring that the number of columns in the union statement matches the original query. The double dash at the end comments out the remainder of the original SQL statement to prevent syntax errors. Now I will send the request. We receive an HTTP 200 response, which indicates that the query executed successfully. Let's examine the response more closely. As you can see, the result appears directly within the page response. The server returned a normal HTML page, and our injected version string has been embedded into the page content. Here we can clearly see the database name and version. Oracle Database 11G Express Edition Release 11.2020 64-bit production. This confirms that we successfully extracted the Oracle Database version using a Union-based SQL injection. Let's quickly summarize what we did in this lab. First, we identified a SQL injection vulnerability in the category parameter. Then, we determined the correct number of columns using the order by technique. After that, which columns were compatible with text data using a union select test payload. Because this was an Oracle backend, we used the special dual table and applied Oracle-specific syntax. Finally, we extracted the database version from the version view using a union-based SQL injection. The key takeaway from this lab is that once the column count and data types are correctly aligned, union-based SQL injection allows us to extract controlled information from the database. In the next video, we'll use the same union-based technique, but adapt it to MySQL and a Microsoft SQL Server, since each database uses slightly different syntax. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.